This is probability distributions. A discrete random variable is a variable whose value is the numerical outcome of an event. You don't need to memorize that. I'm just trying to get you used to seeing some crazy words that you're going to see in college. All right, so a discrete random variable, a variable whose value is the numerical outcome of an event. A probability distribution is a function that maps the sample space. If this makes no sense, you'll be okay. It is a function that maps the sample space to the probabilities of the outcomes in the sample space, which can be visually represented by a histogram. Anybody want more time to write? Okay, we are skipping number 1. We're going to number 2. The instructor of a large class gives 15% of A's and D's. That means they give 15% A's and 15% D's, 30% B's and C's, and 10% F's. Let X be the random variable assigned to the student's grade on a 4-point scale. So that's kind of like GPA, where for an A you get 4 points, for a B you get 3 points, and so on. So for student's grade, you can make an A. What else could you make? A B, a C, a D, or a F. Okay, so those are your choices for grades, A, B, C, D, or F. What did we just say? How many points do you get for making an A on your GPA? 4. It says it right here. An A is 4. What does it say B is? 3. And then it says etc., which means continue the pattern. So what do you think a C would be? 2 and a D, 1 and an F, 0. Okay? Now, probability, that's what we've been doing all week, is the same thing as the percent of people who would get it. So what percent does the word problem say get A's? How many people get A's? 15%. It says it right up here. So let's write it as a decimal, 0.15. 0.15. Okay? What percent of the class gets B's? 30%. How would you write that? 0.30 get B's. Okay? What percent get C's? 0.30. All right. What percent get D's? 15. You got to go back to the front of the word problem. And what percent get F's? 10. Okay? All right. There is going to be one question like this on the test on Friday. If a student is selected at random from this class, what grade would you expect them to have? Go ahead and circle or underline expect. Whenever it asks you what to expect, this is how you do it. You take these two numbers and you multiply them. So you do 4 times 0.15. You multiply 4 times 0.15 plus 3 times 0.30 plus 2 times, what do you think? 0.30 plus, what do you think comes next? 1 times 0.15. And then what's 0 times 0.10? Just 0. Okay? And you have to type all that in your calculator. And anybody can give me the answer. What you got? Okay, let's go back and answer the question. If a student is selected at random from this class, what grade would we expect them to have? So we still haven't answered it. A 2.25 is what grade? A C. All right, so we would expect them to have a C. 2.25 falls in the C category. Okay. All right, this question is just common sense. What percent of the class is passing? Well, what percent had F's? 10% had F's, so what percent of the class is passing? 90%. Okay. All right. Here's another common sense question. What percent of the class has a B or better? So that means they have a B or they have a A. Well, what percent had, we'll do B first. What percent had B? 30%. What percent had A's? 15%. And what does OR mean to do? Add. So 45% have a B or better. Okay. All right, last example. The table shows the probabilities for the number of people who live in a typical U.S. household. So you have the number of occupants. What does that mean? How many people live there? And then you have the probability. What is the probability of people in the U.S. living in a household with 3 occupants? Well, as you see, 3 is missing. Anybody have an idea on how we could find the missing one? Add them all up. Good, and subtract it from 100. So go ahead and add them up. 0.25 plus 0.32 plus 0.15 plus 0.07 plus 0.03 plus 0.01. What you got? I don't want the answer. What do you get when you add them up? Okay, so you get 0.83, and that's the same thing as what percent? 83%, and then you have to subtract it from 100. So 100 minus 83 gives you 17. So 17%, or here, let's make it 0.17 in the table. Okay. All right, questions on how we got that? Okay, if a random U.S. household is selected, how many occupants would we expect to find living there? Okay, so when you see the word expect, that's where you do 1 times 0.25. What symbol do I put next? Plus 2 times 0.32. Plus 3 times 0.17 plus 4 times 0.15 plus 5 times 0.07 plus 6 times 0.03 plus 7 times 0.01. What is it? Okay. What does that mean, 2.6? 2.6 what? Occupants. So I know you can't have 0.6 of a person. It's the average, okay? All right. What percent of U.S. households have at least 5? This is where people get tripped up. If you have at least 5 people, what does that mean? 5 or more. 5 or more. So that means in this particular problem, I could have 5 people, or I could have 6, or I could have 7, and then it stops. Okay? So that's not my answer. I'm just setting it up. So you could have 5 or 6 or 7. So what percent was 5? Yep, I'll just say 7%. What does OR mean to do? Add. What percent was 6 people? 3%. And OR means to add. And what percent was 7? 1%. So what do you get when you add it up? 11%. Okay. All right, and last question. What percent of U.S. households have no more than 3? I always get tripped up on this one. No more than 3 means what? 3 or less. So in this particular problem, what would be our choices? 1 or 2 or 3. Okay? So what percent have 1 people in their house? 25%. Or means 2. Add. What percent have 2? And what percent have 3? Yeah. What is it? Anybody have a question?